So this is Lab 1 charge tapes, and this is the first lab in Physics 2212. All right, so just for some background, the purpose of this lab is to observe the transfer of electrons between two pieces of tape. And this lab is broken into two parts. In the first part, we experimentally determine the charge of the U-tape, and we'll explain a little bit what a U-tape is later in the presentation. And the second part of this lab is to create a computational model to also determine the charge of the tape. And some assumptions for this glow script model that we made are that there is no air resistance, that the charges on each piece of tape are the same, and that each piece of tape is treated as a point charge. Okay, so just a brief overview of the results of this lab. We found that the charged pieces of tape repelled each other, and the charged pieces of tape were determined to be positively charged. We determined experimentally that the charge on each piece of tape was 8.755 times 10 to the minus 8 coulombs, and that the charge on each piece of tape determined by glow script was determined to be 8.75991 times 10 to the minus 9 coulombs. And you can see that there's a little bit of a discrepancy there, which can be attributed to errors in the lab. So each piece of tape was also determined to be deficient of about 5.47 times 10 to the 11 electrons. And that makes sense because the tape had an overall positive charge. Some of the errors that I was describing earlier are from not considering air resistance. We just completely ignored the drag force and the potential loss of more electrons from handling. And we also assumed that the tape was a point charge, which isn't actually accurate to real life. Okay, so getting into the procedure of the experiment, we considered as the system tape B and the surroundings as tape A and the earth, pretty much everything that wasn't tape B. And the initial conditions for this lab are two neutral pieces of tape, A and B, and a third neutral tape that is stuck to the table. And so the procedure was to stick a U tape on top of the base tape. And the U tape was each tape that we were testing, which was A and B, and we one at a time stuck them to the base tape and quickly ripped the base tape or the U tape, sorry, off, creating a charge on the U tape. And we hung each of these U tapes near objects of different charges to determine its charge, and we even hovered the U tapes over each other to see tape A float on top of tape B. And we measured the distance between tape A and tape B when it was floating in the air, and we were able to determine the magnitude of tape A's charge. Okay, so some of the results of this physical experiment that we did were that tape A and tape B repelled each other, that each U-tape, when it was brought to neutral objects like a hand or a book, it was attracted to the hand and the book. Also, that the U-tape was attracted to the negatively charged pen. And so we were able to conclude that the U-tape was positively charged and therefore that the U-tape lost electrons. Okay, so some of the calculations that we made in this lab stemmed from us taking the tape length and the tape mass and the distance between the tapes, and we were able to plug these into this formula here. And basically, what was happening was that the electric field was directly canceling the gravitational field because we noticed that the tape was suspended in air, it wasn't moving, and so the net momentum was zero, therefore the net force on the top tape was zero, and therefore because F net equaled zero, we could equate the gravitational force and the electric force. And so here, when we equated the electric force with the gravitational force, we were then able to solve for the magnitude of the charge, which was 8.755 times 10 to the minus 8 coulombs. Okay, so we were able to determine the number of electrons that the tape was deficient by, and we found this by taking the charge that we found earlier, that 8.755 times 10 to the minus 8 number, and dividing it by the charge of an electron, which we know is 1.6 times 10 to the minus 19 coulombs. And when we divided this out, we found that the tape had a deficiency of 5.47 times 10 to the 11 electrons. And again, electrons were lost because the charge on the tape was overall positive. And then here you can see this modeled in the glow script code. This orange arrow is the electric force, and this downward green arrow is the gravitational force. And they cancel out. The tape is not moving. It is suspended in air, and they balance out. All right, so we're going to address the what if questions. What if electrons had positive charge and protons had negative charge? What would you change about the observations you made with your tapes and other charged objects? And the observations I made would have remained exactly the same. Even if the charge conventions have switched in this scenario, the charge would still behave the same way, with like charges repelling and unlike charges attracting. So if the charged pieces of tape were now negative instead of positive, they still would have repelled each other and would be attracted to the now positive pen, which was negative before. Okay, and why is it important to handle the charge tapes as little as possible? What happens when the charge tapes come into contact with your hands or other objects? And it's important to handle the charge tapes as little as possible to ensure that they remain charged. When they came into contact with my hands or other neutral objects, they might have began to neutralize themselves by gaining back some of the electrodes that they lost, and this would have skewed the experiment results. All right, so just so we can conclude this lab, we noticed that everyday objects can be used to model point charges and observe electric interactions by charging them. We also found that Newton's laws of forces can play an important role in determining individual qualities associated with an object. So we were able to find charge Q from Newton's just F equals ma. And then we found that objects can easily and accidentally be slightly charged through touch alone, which caused some of the errors in our data. And we found that electric forces and fields account for many physical interactions that occur. That is all I have for today. Thank you so much for watching.